All right, y'all. So, first material for our third test. So, 8.1 is going to deal with polynomial functions. Also, the first thing we're going to look at are how to predict what these polynomials will look like. So, what we're talking about is the end behavior of the graphs as those x's head towards negative infinity and positive infinity. So what does the graph do as it's heading out towards infinity? So what we're going to do is make a chart to help us predict what the ends of the graphs will look like. So y'all, this will be an end behavior chart. Okay, so actually this chart will be good for some of the problems in 8.1 and in 8.2. So y'all, the first thing I look at on the graphs, I look at the degree of the polynomial. So the degree of a polynomial is the highest exponent. Okay, so I'm going to look at the degree, which is the highest exponent. That exponent is either going to be even or odd. All right, so the degree is going to be even or odd. Then I look at the sign of the lead coefficient. So the lead coefficient. And y'all, the lead coefficient is the number in front of the variable that has the highest exponent, okay? Now, this lead coefficient can be positive or the lead coefficient can be negative. So this is going to give us a chart with four different options to choose, okay? So the degree is even. I'll have this first case. If the lead coefficient is positive, then this will look like those parabolas. Both ends will go up. Now, they don't connect the middle because depending how high that exponent is, there could be a lot of terms in here, okay? But in the long run, both ends will go up if it's an even degree with a positive lead coefficient. Now, if I throw a negative in front of the lead coefficient, if it's negative and the degree is still even, y'all, just like we were doing to them parabolas, this will flip the graph over if it's negative. So the x squareds, x fours, x to the sixth, all of them are even. So they'll have one of these two options depending on the lead coefficient. So if they're odd, that'd be like the cube graphs, x to the fifth graphs, x to the seventh graphs. If they're odd and the lead coefficient is positive, these graphs will go uphill left to right. So just like the cubes, they go uphill left to right. If it's a positive lead coefficient, but y'all, if I throw a negative in front of that odd degree, then these graphs will look like they're going downhill left to right. So first you look at the degree, even or odd. Then you look at the lead coefficient, positive or negative, and we're going to choose one of these four graphs. So y'all, this would be a good chart to keep handy Okay. Now for my examples, I'm going to label these A, B, C, and D so that y'all can choose one of the four pictures that y'all think might be the answers, okay? So y'all, these examples will say select the sketch that best describes the end behavior of the graph. Okay, so it'll be one of these four. So y'all, my first problem is f of x equals a square root of 11 x cubed plus 5x squared minus 3x plus 5. So y'all, I'm going to get the ball rolling on this one and show you what I'm looking at in order to choose one of my four diagrams. So I said the degree was the highest exponent. We are the highest exponent here is a 3. So since 3 is odd, it's going to be one of these two choices, uphill or downhill. So then I look at the lead coefficient. The lead coefficient is a square root of 11. But I don't care what it equals. I just want to know, is it positive or negative? And y'all, that square root of 11 is positive. So I got an odd degree with a positive lead coefficient. Would I choose A, B, C, or D? And y'all, I'm going to bring up Chad up here for y'all to pick one of those. So what I got a B. So B, good job. This is odd and a positive lead coefficient. So good job, y'all. That would definitely be B, which is uphill, left to right. All right, y'all. So the next one, P of X equals negative pi x to the sixth plus an x to the fifth minus an x to the fourth minus an x plus 9. So y'all, these look long, but that's what polynomial means. Many terms. And these are terms are all the stuff that's separated by the adding and subtracting. So this one has 1, 2, 3, 4, 5 terms that are being separated by the adding and subtracting. So y'all, that's what polynomial actually means, okay? All right. So going off of this, would y'all choose A, B, C, or D?
D.
All right, so I'm getting a C, and you're saying, all right, I got another C. I heard something, but I couldn't tell what y'all were saying.
I said D.
D. Okay, so we got C and D. So y'all, let's see what we're looking at. First, I'm looking at the degree. So the degree is an even number 6. So, I got you on the D because remember, since 6 is even, it's going to be one of these two. Okay.
Okay, we only looking at the first coefficient. Okay.
The first, well, if it's the highest, sometimes they'll put them out of order, but you're looking for the single term that has the highest exponent. And then I'm looking at this lead coefficient. So you're right on that because it was a negative lead coefficient, but it was a negative lead coefficient with an even degree. So y'all, this should be both ends going down. All right, so let's see what we do on 3 here. F of x is going to equal negative 3.2 x to the fourth plus x to the sixth plus 0.4 x to the seventh. And if you look at this one's not in descending order. If it was in descending order, the 0.4 x to 7 would be first, then the x to the 6, then that negative 3.2 x to the 4. So y'all, on this one, the degree is 7 because that's the highest exponent. And I'm looking at the 0.4, which is the number in front of the variable with the highest exponent. So 0.4 is positive. So y'all, we got a odd degree with a positive lead coefficient. So let's see, what are y'all putting? Looks like y'all are all putting B on there. So let's see. Odd degree is this column. Positive lead coefficient is this row. So y'all are definitely right. B, this one's going to go uphill, left to right. All right, y'all. So one more of those, and then we'll move into something different. So f of x equals 7 plus 1 over 7x to the fourth minus 2 over 5x to the third. Y'all, this one's all mixed up. So find your degree on here and then find your lead coefficient and tell me, is this one A, B, C, or D? So let me just ask you. All right, Caleb, you got an A. Mine got an A. Darren got an A. So good job. Y'all, this leading term will be the highest exponent. So that gave me a degree 4, which was even. That 1/7 is positive. So good job. Even and positive goes with A, which has both ends going up. So y'all, that's the trick on the first 4. Find your highest exponent and then the number in front of that highest exponent and get your columns and your rows what you need and pick your sketch that you need, okay? All right, y'all. So on number 5, we're going to look at our next topic in here is finding zeros. Now, if a number is a zero of a polynomial, then the result of substituting that number, substituting that number into the polynomial must be 0. And y'all, that's what it means to be a 0. I take the number, plug it into the polynomial, do my order of operations. If I get 0, then that means the number was a 0 of the polynomial. So an example of this, we're going to use substitution to determine if 4 is a 0 of f of x equals x cubed minus 10x squared plus 12x plus 48. So y'all, what I mean on this one, since I'm checking 4, I'm going to be finding f of 4. So just remember, this is just letting me know that I'm putting a 4 in for all the x's, okay? So that'll give me 4 cubed minus 10 times 4 squared plus 12 times 4 plus 48. And y'all, at this point, you could punch this in the calculator, but I'm going to actually work it by hand to see what we get. So first, I'm going to do the exponents. So that would be 4 cubed. So 4 times 4 times 4 is 64 minus 10 times my 4 squared. Well, 4 times 4 gives me 16. And then, y'all, I'm just bringing everything else down. So on that step, I just did the exponents. Now I'm going to do the multiplying. So I got to multiply this, and I got to multiply that. So everything else is coming down. So I'm bringing down my 64. This will be minus 10 times 16. So that'll be minus 160. This will be plus 12 times 4, which is 48. And y'all at the end, bring down that 48. All right, y'all. So one of y'all punch that in and tell me what that gives me for an answer. So I got a 64 minus 160 plus my 48 plus my 48. All right, so we got a 0 on that. Good job, Maya, because 64 minus 160 is a negative 96. 48 and 48 is a positive 96. So the negative 96, positive 96, give me an answer of 0. So they want me to determine if 4 is a 0. I got a 0 remainder. So y'all, that would be a yes answer. So this one was like number 5. Um, so on number 5, you'll either do a yes or no answer on that, okay? All right, y'all. So now the big thing in this section is finding zeros. So we're going to be finding zeros of a polynomial. So y'all, the first thing I need to do, if needed, sometimes they're already factored, but the first thing I need to do, if needed, is factor the polynomial. And like I said, that's if needed. Now, once I got this polynomial factored, I'm going to set each factor equal to 0. So set each factor equal to 0 and solve. So just like I did when we was solving the quadratic equations in the last chapter by factoring, once we got it factored, I set each of those factors equal to 0 and we solved it. All right, y'all, so this will give me the zeros. So the next term you're going to learn is the multiplicity. So you're going to state the multiplicity of each zero. All right, so what is multiplicity, y'all? Multiplicity is the number of times that a zero occurs. It's the number of times that a zero occurs, and it's equal to the exponent outside of the parentheses. Okay? So your factors will be in parentheses. If they have exponents, those exponents are the multiplicity. It's how many times the zero occurs. Now, if it's just a single factor like an x cubed or a 2x squared, if it's a single factor, then the exponent is the multiplicity. Okay? So y'all, I'll show y'all examples doing this. They'll start out factored, and then I think they got one, two, three examples where they're already factored. And then we'll have two examples where we got to factor it, okay? So they're going to give us a little of both in this section. So these examples start at 6. And these examples will say, find the zero of the polynomial and state the multiplicities of each. All right, y'all. So these start at number 6. They're giving me f of x equals x squared minus 25 all raised to the fourth. So technically, we're treating this as it's already factored. This exponent 4 means you got an x squared minus 25, x squared minus 25, x squared minus 25, x squared minus 25. So that's why we're using the exponent for shorthand. So on this example, the exponent 4 will be what I use to get my multiplicity. And this factor, the x squared minus 25, is what I'm going to set equal to 0 to find those zeros. So I'm going to set x squared minus 25 equal to 0. And y'all, I'm going to show you how we can solve these are quadratic equations with the x squared. I'm going to show you the third way to solve a quadratic equation that is missing the x term in the middle. Notice I got the x squared term, the number term, but I don't have an x in the middle. So if you don't have the x term, when you solve a quadratic like this, the easiest way to solve this is to solve it by taking square roots. Okay? Because for me to solve this by factoring, it's got to be able to be factored. And solving it by the quadratic formula, A would be 1, B would be 0, C would be negative 25. That takes a lot of time doing that quadratic formula. So y'all watch me solve this one by taking square roots. So if I'm going to solve it by taking square roots, my first move is to get this x squared on one side by itself. So I'm going to move this negative 25 to the other side by adding 25. So y'all, at this point, I get my x squared on the left side, and then 0 plus 25 gives me 25 on the right side. Now, when you're solving equations, the exponent on the variable lets me know how many answers I'm going to get. So since I'm dealing with an x squared, I got to get two answers, okay? Just like when we did the quadratic formula, and just like if you'd have factored it. So at this point, what I'm going to do is I'm going to take square roots of both sides. Because remember, what I do to one side, I got to do to the other side. So y'all, I'm going to take a square root. So the square root of x squared, that square root and that exponent cancel each other out, and I'm left with an x. So y'all, the question for y'all, what is the square root of 25? All right, Darren, that's one of them. I need the other one. Because remember, y'all got to get me two answers, because that had an exponent of 2 on it. So let me ask y'all this. What was in front of that square root radical on that quadratic formula? Oh, so y'all let me get you. Okay, so let me show you. So Darren, you're half right. But anytime we do a square root of a number, you got to use that plus or minus in front of the number. So the square root of 25 is a plus or minus 5. Okay, 5 times 5 equals 25. Negative 5 times negative 5 equals 25. So square roots got two answers, a plus or minus, and then that number. So y'all on MathLab, I would pick the one that says the zeros are a plus or minus 5. Each of multiplicity. Well, what's my multiplicity? Well, right here, I said this exponent outside those parentheses was my multiplicity. So my multiplicity would be a 4. Because y'all, like I said, if you wrote this out 4 times and solved every one of them, you'd get plus or minus 5, and it would happen every time you did it, okay? So plus or minus 5 multiplicity 4. All right, y'all, any questions on that? So we'll knock out another one. My 7 has f of x equals x to the third times x minus 5 squared times x plus 9. All right, so this one has a multiplicity of 3. So that'll be my multiplicity on the first factor. The second one has a multiplicity of 2. But y'all, there's not an exponent outside of this x plus 9. So what exponent would we treat like being there? Oh my, that was quick. That is definitely treat it like a 1. So if we do not have an exponent, make that a 1. All right, good job, y'all. All righty, so I know my multiplicities are going to be 3, 2, and 1. So now to find my zeros, I'm going to set x equal to 0. And although that's got an exponent of 3, we're not worried about the exponent right now. That's going to be our multiplicity. We're just going to set each of the factors equal to 0. So x equals 0, x minus 5 equals 0. And this last one's x plus 9 equals 0. So anytime you got a single x like this, I don't care what the exponent is, it's always going to equal 0. Now the other two that was in parentheses, we're going to solve both of these for the x's. So y'all on this one, I'm going to add 5 to get my 0. So I get x is a positive 5. And then here to solve for x, I will subtract the 9. And I get x equals negative 9. All right, y'all, so let me show you how the answers will be. In MathLab, it'll say the smallest 0 is blank with multiplicity blank. Then it says the middle 0 is blank with multiplicity blank. And then finally, the largest 0 is blank with multiplicity blank. All right, so I got a 0, a positive 5, and a negative 9. Out of these 3 zeros, which one would y'all put as the smallest? Oh, now mine, don't worry about the multiplicities yet. We'll worry about the multiplicities in a second. What we want to know is what's the smallest number between a 0, a 5, and a negative 9. All right, Jan. Okay, so y'all are good now. Y'all got negative 9. Good job. Now, the 0 of negative 9, what would its multiplicity be? Now I'm looking at the exponents, and that would definitely be a 1. Because negative 9 came from this factor, and it had multiplicity 1. All righty. So now, what is the middle 0 of these 3 numbers? Which one would be my middle? And really, I'm down to 0 and 5. So good job. 0 is going to be the middle. So what was its multiplicity? All right, good job. It is a 3 on that one. Because remember, you're looking at the exponents of the factors that you set equal to 0. So this one had an exponent of 3. So that gives me a multiplicity of 3. So y'all, if you got single variables like this, their exponent automatically becomes their multiplicity. All right, so one left, y'all. I need my largest 0. And y'all, there's only one left. Good job. It's got to be 5. With a multiplicity of what? All right, y'all rolling in. So that one had a multiplicity of 2. So 5 came from this x minus 5, and that had an exponent of 2. Good job. All right, y'all. So let me do one more of those, and then, like I said, we'll get into some of these where we got to factor them. All right, so let me get this camera back up. All right, so this will be like y'all's number 8. F of x equals -6 times x minus 1 to the 4th times x plus 5 to the 3rd times x squared. All right, so technically I got 1, 2, 3, 4 factors on this problem. But y'all, one of these I'm going to cancel out because there's no way I can set this one factor equal to 0. And that's at -6. If you got a number out front that does not have a variable with it, then what I would do to that number, cross it out. Because you cannot set a -6 equal to 0. We're only concerned with the factors that have variables in them, okay? All right, so uh, looks like I got exponents on everything. So I'm going to set my 3 factors equal to 0. I'm going to set x minus 1 equal to 0. I'm going to set x plus 5 equal to 0. And then here, I'm going to set x equal to 0. And y'all look at that. Once again, the single x variable gave me 0 as an answer. And guess what? It'll do that 100%. Single variable always equals 0. All right, y'all, these two we're going to solve. So here we'll just add 1. And again, x equals a positive 1. Here we'll subtract 5 to get the x by itself. And we get x equals -5. So y'all let me write out how they do these answers on this one. It starts out, it says the 0, 1 has multiplicity blank. Blank is a 0 of multiplicity 3. And y'all finally, the remaining 0 is blank. It has multiplicity blank. So y'all, this is on y'all. Answer this first blank. The 0, 1 has multiplicity what? All right, mine, Darren, good job. Definitely a 4 because they got the 1 from this factor and then had that exponent of 4. So then fill in this blank. Blank is a 0 of multiplicity 3. Whoa, that's fast, y'all. -5 was quick on that one. And there it is. -5 came from this factor that had a multiplicity of 3. Good job. All right, y'all, you got to put two things on this one. The remaining 0 is blank, and it has multiplicity of blank. So, dang, y'all got that up there quick, too, because the remaining 0 is 0, and that one had a multiplicity of 2. All right, good job. So, y'all, that is 6, 7, and 8. They're already going to be sort of factored. You just got to set each of the factors equal to 0, solve them, and then figure out those multiplicities by those exponents. But y'all, number 9 changes the game. Number 9. They're giving me f of x equals x to the third minus a 7x squared minus a x plus 7. So they gave us a 4-term polynomial. What we got to do is try to factor this so that we got factors with parentheses or x's with exponents or something like that. So we got to factor a 4-term polynomial. So y'all, I'm going to show you how I factor these. I factor 4-term polynomials by grouping. And y'all, I'm going to do exactly what it says. Factor by grouping. I'm going to make 2 groups over here. I'm going to group the first 2 terms together. So the x cubed minus 7x squared. And then I'll group the second 2 terms together. So I've got 2 groups now. The first 2 and the last 2. So from each of these groups, what I'm going to do, I'm going to factor out the greatest common factor from each group. Okay, so first I got an x cubed and a minus 7x squared. So the greatest common factor is the largest factor that would be common between the x3 and the x squared. So it's not going to be a number because all you got is a 1 in front of the x cubed and a -7 in front of the x squared. Now, Maya, you are definitely close. But this one has 3 x's and this one has 2 x's. So when you're comparing variables, the greatest common factor will be the variable with the lowest exponent. So the GCF would actually be an x squared, but you is right on it. It's got to be the variable only, okay? So y'all, this one has x times x times x. This one has an x times x. So both of them had at least 2 x's in them, okay? Now what I want to know, when you factor out a GCF, you're basically dividing both of these by that x squared. So what would go here for my x cubed divided by my x squared? What's left? Y'all, that's what y'all are doing to them h's basically. Remember, you had to divide them h's. So if I got an x cubed and I divided out an x squared, so y'all on the side, that would be this. X cubed divided by x squared. What's that give me? X cubed over x squared is just an x. So that means this will be an x minus. All right, so you got a 7x squared. You're going to divide out that x squared also, Maya. So both of them have to be divided by the x squared. So y'all, what is this? A negative 7x squared divided by x squared. What would this give me? If you got a negative 7x squared and you divide by the x squared, what's that going to give us? All right, so that's going to give me my negative 7, right? Because y'all, the x squareds are going to cancel on that one, leaving the negative 7. All righty, so that's what I was doing to get what was in the parentheses here. Now, the second GCF. Since this third term is negative, the second GCF will be negative. Okay? So y'all remember that. The second GCF always has the same sign as this third term here. Okay? Alrighty, so y'all, what is the only common factor that I can divide out of a x and a 7? There's only one factor in the world that they would have in common. Uh-oh, y'all, I got you on that. So if you got 2, okay, I'm going to go with a 1. Good job. If your variable and number have no other common factor, they at least have a 1, okay? So, if this third term is negative, you're factoring out basically a negative 1. If this was positive, you'd be factoring out a positive 1. So I need what's going in these parentheses. What's a negative x divided by negative 1 give me? So y'all, a negative x divided by negative 1. What's that give us? All right, so basically a negative divided by negative is a positive. Good job. So that means a negative x divided by negative 1, y'all, that's going to give me a positive x. So that's going right here. So what will you get when you take a 7, divide that by negative 1? That's going to give us a negative 7. Good job. All righty. So I took both of these, divided by x squared, and got an x minus 7. I took both of these, divided by the negative 1, and got an x minus 7. At this point, we're almost factored. And y'all notice these parentheses must match up at this point. So the parentheses must match. All right, so our parentheses match. So the last step is you're going to factor out that x minus 7. So y'all, here's the thing. I'm factoring out that x minus 7 like a GCF. If I factor out that x minus 7, what's going into second parentheses? That's going to be what's on the outside. So the x minus 7 comes down as a GCF, and that leaves me to x squared minus 1 for my second parentheses. At this point, we are factored. Now, since I'm factored, I'm going to set this equal to 0. Okay, let me ask y'all this. These parentheses, neither one of these parentheses have an exponent. So what exponent am I going to put for both of these? All right, that's going to be a 1 here and a 1 here. So now we know the multiplicities are going to be 1. And y'all, let me show y'all another trick. The highest exponent on this polynomial was a 3. So that means it's a degree 3. But anytime your highest exponent is a 3, we got to get 3 answers for my zeros. So the highest exponent tells me how many zeros I'm going to get. Now, to find those zeros, we're going to set these factors equal to 0. So set x minus 7 equal to 0. And then you're going to set x squared minus 1 equal to 0. This one will give me one of my zeros. Since this one has an x squared, it'll give me my last two zeros. Okay? So to solve this one, we're going to add 7. And I get x is a positive 7. To solve this one, I got an x squared and a number. So this one I'm going to solve by taking the square roots, just like I did a while ago. So to take square roots, you're going to add 1 to both sides. That way you can get this x squared on the left side by itself, and then the 1 goes to the other side. Now, we're going to take square roots of both sides. So y'all, the square root of x squared is x. So y'all give me my two answers so I can see if y'all figured that out yet. So basically, square root of square root of 1, what you got, plus or minus 1. Good job. So in MATLAB, it'll say the zeros are x equals blank. Each zero has multiplicity blank. So what am I putting in the first blank? For my zeros, well, y'all, here's my 3 zeros. I got a 7, a 1, and a negative 1. Each had a multiplicity of 1 because 1 is the exponent that was outside those parentheses. Okay? So, y'all, I got another one like that, number 9, just to get you good at this 4-term polynomial stuff, okay? All right, y'all, so let me flip that over and get y'all on number 10 then. All right, y'all, same thing on number 10 as number 9. I got f of x equals 2x cubed minus x squared minus the 98x plus 49. All right, so remember, I'm going to factor by grouping again, which means we'll factor the first two groups together, the first two terms, and then the last two terms. And at this point, we're going to factor out our GCFs of each group. All right, y'all, you got a 2x to the third minus a x squared. What is their GCF? Well, on this one, I'm not going to go with the numbers because I got variables that are common. So you got an x cubed here, x times x times x. You got an x squared here, x times x. So the most that they got in common would be x squared, right? You got an x times x here. Here you got an x times x, which is x squared times the x. So since I'm looking at the variables, the GCF is the smallest exponent, which is the x squared. Now, knowing that I'm dividing both of these by x squared, what's going in these parentheses? So y'all, what is 2x cubed divided by x squared? What's that giving me? 2x cubed divided by x squared. All right, so that's going to give me 2x. Oh, Jay, and you know, all righty, you done got this all the way done. Because the negative x squared divided by x squared gave us a -1. Good job. So y'all, to get that -1, we had negative x squared divided by x squared. That's where we got the -1. Now remember, the second GCF is going to be the same sign as that third term. So since this is negative, my second GCF will be negative. So let's see. A 98x and a 49. I wonder what their greatest common factor is. And y'all, I'm going to give you a clue. You need to get a 2 inside them parentheses. So what could you take 98 and divide by to get me a 2? That's going to be the second GCF. Because remember, these parentheses got to match up. So I know whatever I divide these both by better give me a 2x minus 1. All right, so 98 divided by what equals 2? And in here, you got a 49. Well, that's got to end up being a 1. So 49 divided by what will equal 1? So, y'all, what's this GCF going to be? And it's only a number on this one because both of those do not have an X, okay? All right, y'all, so I'm going to show y'all what it is. Because I got a 98, I got to get that to be a 2. So 98 divided by 49. So this second GCF is going to be a -49. Because y'all watch what I had to do. I got -98x. If I divide that by -49, well, what's that giving me? That's going to give me a 2x. That's what I needed right here. And then I need to make this one equal -1. Well, y'all, 49 divided by -49. Guess what? That's going to give me the -1. So that I get a 2x minus 1. Okay, so remember, use what you got here to guide you because you got to get the same thing here. If I'd have picked a 2 and put 2 here, that would have put a 49x in here. That wouldn't match. So you want to get this division down so that you can get what you need in those parentheses. All right, y'all. At this point, I'm pulling out that 2x minus 1. That's going in the first parentheses. What would y'all put in the second parentheses? So if I factor out the 2x minus 1, what's going here? So x squared negative 49. Good job. All right, so we are now factored. And y'all remember, this has an exponent 3 as the highest exponent. So that's telling me I got to get 3 zeros. So this one will give me 1 0. And then that x squared will give me the other 2 zeros. So since I'm factored, I'm going to take this whole expression, set it equal to 0. Y'all, once again, there's no exponents on this. So what are y'all putting for the exponents? Right? So remember, if there's no exponents shown behind those parentheses, we're going to put a 1 there. So the multiplicity is automatically 1 if they don't have those extra parentheses, okay? All right, y'all, let's set these equal to 0 and solve. All right, y'all, so the first one, you're going to take 2 moves this time because you got a number in front of the x. So first thing, get the 2x by itself, add me a 1 to both sides. So you get 2x equals 1. And now to make that a 1x, I'm going to divide by 2. And y'all look at that. That cancels and I get x equals 1/2. So my first 0 is a fraction. Now here, I got an x squared in a number. So I'm going to do the square root again. I'm going to add 49. So that's going to give me my x squared equals 49. We're going to square root that. And y'all, square root of x squared, that cancels, giving me my x. Since I'm taking the square root of a number, that's going to be a plus or minus square root of 49, which is a 7. So for this one, zeros are blank. They all have multiplicity blank. All right, so my zeros are 1/2, 7, and -7. And once again, I had to put ones here, so they all have a multiplicity of 1. Remember, I'm not looking at the exponents on the variable that's in the parentheses. I'm looking for these exponents on the outside of those parentheses, okay? You know, so 9 and 10 were probably your trickiest because they're 4-term polynomials. Yours will be similar, but yet different, okay? So, y'all, I'm going to give us our last topic for the College Algebra 8.1, and then I'll show you how to do the support. So, on this section, I'm going to show you how to figure out if a graph crosses the x-axis. So let me draw this real quick. See, all these graphs will either cross over the x-axis. So like this one crosses over the x-axis, okay? So crosses over the x-axis. But y'all, sometimes the graph will come down, it'll come up, it'll sort of touch that x-axis, and then it turns. Right here, where this one is at, we say this is tangent to the x-axis. So these will either cross all the way over the x-axis or they'll come up and be tangent. And y'all, they can be tangent on this side also. They can come down, touch it, and then turn up, okay? So they can be tangent on top or bottom of the x-axis, okay? So how do I tell? And y'all, I tell by looking at the multiplicity of the zero or the degree. Okay? So I'm basically looking at the degree to determine if the zero, that's the x value of the point, if the zero has a even multiplicity, so if the exponent outside that parentheses that you found that zero is even, then the graph is tangent. So it'll be tangent at the x-axis. It'll come up, almost touch it, and then it turns. And y'all, like I said, that could be either above it or under it, okay? Now, if the zero has an odd multiplicity, then the graph crosses over the x-axis. Okay, so even, tangent, odd, crosses over. Okay? So y'all, these last two are going to be true or false. So let me do number 11 first. If my P of X equals X minus 8 to the fourth times X plus 2 to the ninth, then the graph of the polynomial crosses the x-axis at 8, 0. So let me show you what they're doing. They're giving you the 0, which is 8. So based on them giving me the 0 of 8, do I think this graph crosses over the x-axis at that point, or do we think it's tangent to the x-axis at that point? So basically, they're saying it crosses over at 8, 0. Is that going to be true or false? And also, if the 0 is 8, remember the x-intercepts are equal to the zeros of the polynomial. So if that's an 8, the only factor that could give you a 0 of 8 is the x minus 8 factor, okay? It has a multiplicity of 4. We all while ago, we said if it was even, it was tangent. They said it crosses, so that would be false. Now I would pick the answer that says there's two false ones. Um, One will say the exponent 4 is even, and therefore it crosses at is tangent at 8, 0. And then the other one says 4 is an odd number. So it's wrong based on them saying 4 was an odd number. So let me show you how they do them answers. So I knew this was false because this was an even. So see here, the false has this answer where they're saying 4 is odd, and then false has this answer where they're saying 4 is even. Okay? And that made it tangent. So you want to pick the one that is true or false, but look for what they're saying. The exponents are messing them up. They're saying 4 is odd, 4 is odd. So you can automatically throw them two out and choose between true or false, okay? So knowing that, look here. X minus 4 to the fifth. X plus 3 squared. They're saying the polynomial graph is tangent at -3, 0. Well, remember, it's tangent if it's even. So we're looking for an even exponent on the factor that gave me a 0 of -3. We all -3 had to come from this factor, x plus 3. When you set it equal to 0, you get -3. It has an exponent 2, which is even. So this is true. It's going to be tangent if it's an even degree. But remember, I got to pick, there's two true right here. And this one says 2 is odd. This one says 2 is even. So y'all, I want the one that's got the right exponent being even. So on that one, I would choose B on that one, okay? But y'all, so that was the end of the college algebra. So what I'm going to do is give you the stuff that you're going to need to do the support. So this is what you'll need to do. 8.1 support. All right, so it's basically definitions. So the first definition is a term. And like I was showing you a while ago, the terms of a polynomial are separated by addition and subtraction. All right, then we need to know what is the leading term. Well, that's the term with the highest exponent. Just when we was looking at that in behavior chart, right? We were finding our leading term, which was the one with the highest exponent. The leading coefficient is the number in front of the leading term. So on that chart a while ago, those were the numbers I was using to see if it was going to be positive or negative, okay? All right, y'all, then the degree of the polynomial. The degree was the exponent of the leading term. Which means the highest exponent of the polynomial. All right. Now, we're going to classify the polynomial. So these will be the classes of the polynomials. So I'll give you the name and what degree it has to have. So the name and degree. So the smallest polynomial is a constant polynomial, and that is a degree 0. That'll be something like this. So I'll give you an example. That'll be f of x equals 5. Since there's not a variable that has a degree 0, okay? Next is linear. That is a degree 1. And an example would be, how about 2x plus 3? That exponent that's not shown by the x would actually be a 1. Okay? Quadratic. Well, y'all, we know what degree the quadratics are. We got quadratics from our x squareds. So those exponents were 2. That could be f of x equals x squared plus 3x minus 5. Highest exponent is a 2, making that quadratic. All right, y'all, 2 more. Cubic. Well, cubics have a degree 3. An example could be f of x equals negative 7x cubed minus 2x. Highest exponent's 3. That gives me cubic. And y'all, the last one is quartic. Quartic, like a quarter. It is a degree 4. So that would be like f of x equals 2x to the 4th plus 3x minus 7. So that'd be an example of a quartic. All right, so y'all hang on. I'm going to get MathLab ready while y'all were playing with those for a second. And I'm going to pull up the 8.1 support. And y'all, we'll just go through a few of these just to get you good at them. So the leading term is the term with the highest exponent. Well, y'all, your highest exponent here is a 2. So the leading term is going to be the whole thing. It's going to be negative, and then I'm going to put in a fraction, and that was 1/2. Arrow right, and then put in my x, and then we'll square that. So when you put this in, the leading term has to be the lead coefficient, the variable, and its exponent, okay? So you're going to check that answer. The leading coefficient, well, y'all, right here's the leading term, negative 1/2 x squared. So the number in front of the x squared is the leading term, or leading coefficient. So that'll be the negative 1/2. Okay, so the leading coefficient, that's just a number. Answer, check that. The degree of this polynomial, well, y'all, that's the exponent for the leading term. So that was a 2. So you put in the degree. And then finally, we're going to classify it. So, y'all, what did I say would be the classification if the highest exponent was a 2? Are y'all going with quadratic, cubic, linear, constant, or quartic? All right, quadratic. There you go. Exponent 2s are quadratic. No, that's what we've been doing with them x squareds, right? Those were quadratics, okay? All right, y'all. So I'll let y'all do one more, and then y'all will have the hang of this, and y'all be good to go on your support. So this one, is it cubic, constant, quadratic, linear, or quartic?
Hey, I don't think I can see your screen right now.
Uh, oh, did I not pull up the, dang it. Okay, let me go to my share. So I didn't pull up MathLab on the first one either, did I?
No, I don't think so.
All right, can y'all see this one now?
Yep.
All righty. So I'll do two more since y'all didn't see my first one. I thought y'all was looking at this with me. All righty, y'all. So this one, negative 6x cubed minus 4. Highest exponent's a 3. So when the highest exponent or degree was 3, we said that one would be cubic. So y'all check that answer. What is the leading term of the polynomial? Well, the one that had the highest exponent, that's going to be the negative 6x cubed. So see, this one had two terms. All right, check that answer. The leading coefficient, well, y'all, that's the number in front of the leading term. So that'll be the negative 6. And then finally, the degree, well, that's the highest exponent, which is the exponent on that leading term. So that would be a 3. All right, y'all. So this one's on y'all, okay? So negative 5x to the fourth minus 9. Constant, linear, quartic, cubic, or quadratic. So C, quartic, good job. We said if the highest exponent was 4, you're quartic. So y'all, you would check that. What's the leading term? The first one or the second one? The negative 9 or the other one, the negative 5x4? So y'all, if you don't want to punch the exponent, just do like that, do negative 5. So that'd be the leading term. All righty. The leading coefficient, what are y'all putting there? Oh, remember, so the leading coefficient is the number in front of that leading term. So this is where y'all want to put the negative 5. Okay. Now, on this next one, the degree, that's where y'all going to put the 4 because the degree is the exponent. Okay. All right, y'all, we're doing another one. Getting y'all good at these. All right, the leading term of the polynomial is the term with the highest exponent. So, y'all, that's going to be the x and then the exponent of 4. So that whole x4 is the leading term. Okay? So the leading term is the whole thing. Now, let's see what y'all put here. What is the leading coefficient? What is the number in front of that x4 term? So if there's no number in front of that x squared, it's going to be a 1. So good job. So y'all put 1 on that one. So that's like a 1x to the fourth, okay? So what's the degree of this polynomial? So that's 4 because that's my highest exponent. And then it's probably going to ask y'all the linear, quartic. All right, so what type polynomial is this? Constant, quartic, linear, cubic, quadratic. All right, so that's quartic. Good job. See, y'all, basically, that's what y'all are going to be doing with this support, okay? So there's 6 of them. You just got to list, um, you just got to list leading coefficient, leading term, the degree, and then tell whether it's constant, linear, quartic, or whatever, okay? All right, y'all. So that's everything for tonight. So that'd be 8-1 college algebra, 8-1 support.